SpaceX just fired one engine on Ship 40, not 6. All 6 were fueled, tanks ready, everything set for a full static fire. Then engine 142 lit alone for 15 seconds, while the other 5 stayed dead silent. Compare that to Ship 39, 6 engines, full burn, back in April. Something broke mid-fueling here, and SpaceX cut tanking at just 2/3 full. That's not a routine test, that's a cover story. Here's the real theory. Start with the numbers because numbers don't lie. SpaceX rolled Ship 40 to Massey's test site on June 25th. The plan on paper looked routine. Load both tanks, run a full 6-engine static fire, the same test Ship 39 completed back in April. Every camera at Starbase was pointed at that stand, expecting a familiar blast of orange flame and 6 engine bells lighting up at once. That's not what happened. The oxygen tanks stopped filling at roughly 2/3 capacity. The methane load was even smaller, just a trickle compared to what a full static fire requires. Then, silence. No countdown to a 6-engine burn. Instead, one center engine, designated 142, lit alone for 15 seconds while its 5 neighbors sat completely dark. Here's why that detail matters more than it sounds. A full static fire needs full tanks, full pressure, full flow through every feed line simultaneously. Stopping fueling at 2/3 isn't a rounding error. It's a decision. Someone in that control room looked at incoming data mid-fueling and pulled the plug on the original plan. So the real question isn't why did only one engine fire? The real question is, what did SpaceX's engineers see in that fueling data that made them switch plans in real time? What one silent engine actually proves. Here's where most coverage stopped. They saw one engine fire instead of 6, called it an anomaly, and moved on. That misses the more interesting story hiding inside the data. Think about what a single engine test can and cannot tell you. If you're worried about a crack in the tank wall, or a weld failure in the airframe, you don't light any engine. You don't want ignition anywhere near a structural problem, because a compromised tank under ignition stress is exactly how you lose a vehicle on the stand. The fact that SpaceX chose to fire engine 142 at all, even for a shortened 15-second burn, is itself a signal. It tells you the tanks held pressure. It tells you the plumbing that feeds propellant into that engine was intact. It tells you the core vehicle was healthy enough to trust with an active burn. That narrows the suspect list dramatically. The issue almost certainly wasn't structural. It wasn't a tank problem. It was something upstream, something in the fueling sequence itself, or possibly an issue with one of the other 5 engines that showed up during pre-test checkouts. Rather than scrub the entire test and lose the data window, SpaceX appears to have salvaged what they could. A single clean engine firing, filmed in gorgeous detail from inside the engine skirt, while the rest of the stack stayed dark until whatever tripped the alarm gets fixed. This is the difference between a failure and a decision. A failure means something breaks and you find out the hard way. A decision means your team catches a problem before it becomes one, and adapts the test plan on the fly to still walk away with usable data. SpaceX rolled Ship 40 back to Megabay 2 on June 26th, one day after the shortened test. It's not a ship in crisis. It's a ship headed back to the shop for a fix the team already understands. Comparing Ship 39 and Ship 40. Compare the 2 build campaigns side by side, and the pattern becomes obvious. Ship 39 rolled to Massey's, ran through spin prime tests and tanking runs, then completed a clean full-duration, 6-engine static fire on April 14th. No single-engine test anywhere in that sequence. 3 weeks later, on May 8th, it moved to the launch site. Ship 40 broke that pattern, and when a company known for repeating a proven procedure suddenly deviates from it, that deviation is data in itself. It tells you something unplanned entered the sequence. The most reasonable read. A problem surfaced late enough in the countdown that scrubbing entirely would have wasted a test window. SpaceX didn't want to waste, so engineers repurposed the attempt into something smaller but still useful. Expect Ship 40 to return to Massey's soon, this time to finish the job. Ship 39 already completed months ago. A full 6-engine burn. Tanks completely full. Every engine bell lit at once. When that happens, we'll know exactly what the fix was, because SpaceX's public messaging usually gets more specific once a corrected test succeeds. Here's the part that actually changes how you should read this whole story. While Ship 40 was rolling backward toward the factory for repairs, a second vehicle, Ship 41, was rolling forward out to Massey's on June 28th, just 2 days later. That timing is not a coincidence. That is a manufacturing strategy playing out in real time. SpaceX isn't waiting for Ship 40 to finish its campaign before starting the next one. They're running 2 version 3 Starships through test campaigns simultaneously, and that overlap is the entire point. Think of it like a factory assembly line where a single stalled station doesn't stop the whole line, because a second line is already moving parts through the next stage. If Ship 40 needs an extra 2 weeks to sort out its fueling issue, that delay doesn't ripple through the entire flight schedule, because Ship 41 is already accumulating its own test data on a separate track. One ship stumbling doesn't cost SpaceX the whole month. It costs them nothing more than a footnote. Ship 41's first job at Massey's is a cryogenic proof test. Picture filling the tanks with an inert, super cold liquid instead of actual rocket fuel, then pressurizing the structure to its operating limits. It's the same principle as pressure testing a new pipe before you ever run water through it under real conditions. You want to find a weak weld or a hairline flaw while the tank is filled with something harmless, not while it's loaded with a few hundred tons of combustible propellant. Every new Starship has to pass this test before it earns the right to be fueled with anything that can actually explode. Where this puts Flight 13 and Flight 14. Now here's where the story gets genuinely predictive, not just descriptive. Ship 40 took 52 days from the start of its cryogenic testing on May 3rd to reaching static fire testing on June 24th. Apply that same 52-day window to Ship 41, which began its cryo campaign on June 28th, and you land on a rough target of August 19th for Ship 41 to be flight ready. Now stack the flights. If Flight 13 launches in mid-July and a flight-ready Ship 41 lands around August 19th, Flight 14 becomes plausible by the end of August. That would mean 3 Starship flights, 12, 13, and 14, inside roughly 100 days. For a vehicle generation that only flew for the first time in late May, that cadence, if it holds, would mark a real step change in how fast SpaceX can turn hardware around. And Flight 14 carries extra weight in that scenario. Several signals suggest it could be the mission where SpaceX attempts its first super heavy catch with this generation of hardware, assuming Flight 13 proves the booster and ship systems are reliable enough to build on. None of this is confirmed by SpaceX. It's a projection built from the pattern in front of us, and patterns can break. But if it holds, a 15-second single-engine burn in June quietly sets up one of the biggest milestones left on the Starship roadmap. Ship 40 has one more story attached to it, and it connects directly back to the theme of engineers solving small problems before they become expensive ones. Back in March, unusual white tiles appeared on a Starship nose cone inside the factory, sitting in the same position where the standard black heat shield tiles normally go. At the time, the leading guess was thermal insulation, something SpaceX might be testing for a tanker variant or the lunar lander version of Starship, since a reflective white surface manages heat differently than the black ablative tiles used for atmospheric re-entry. New photos change that picture. The white tiles are back, this time on the nose tip itself, sized correctly to match the smaller half-size tiles used specifically at the tip's tighter curve. And this time, photographers caught them from an angle that reveals what's underneath. There's no black insulation layer, no white mineral felt padding for burn-through protection, just a visible gap between the tile and the hull. That gap changes the entire theory. A tile meant to survive re-entry heat needs multiple layers underneath it to manage that heat load. A tile with nothing but open air behind it isn't built to survive re-entry at all. So insulation stops being the most likely answer. The stronger explanation, these are placeholder tiles, protecting the attachment pins that hold the real heat shield in place while the ship is still being built inside the factory. If a technician bumps one of those exposed pins hard enough to bend it, that's a repair that can take days. Worse, a damaged pin that goes unnoticed can cause a real tile to detach mid-flight, which has already happened on multiple previous Starship missions. Covering the pins with a cheap, replaceable white tile during manufacturing removes that risk entirely. It's a less dramatic answer than a secret lunar lander variant. But it fits the evidence better, and it fits the larger pattern running through this entire story. SpaceX repeatedly choosing the practical fix that prevents a bigger problem down the line over the flashy explanation that generates more headlines. Why one ship's hiccup barely registers. Zoom out, and Ship 40's single-engine test stops looking like a setback at all. It starts looking like proof of exactly the operational philosophy SpaceX has been building toward for years. Redundant infrastructure, overlapping manufacturing lines, and enough backup that no single failure point can stall the entire program. That philosophy extends past the ships themselves. At Starbase, workers are currently excavating buried concrete and rebar left over from the original launch pad to make room for a new flame trench, tougher and slower work than building from scratch. But watch how they're building the ground support bunker alongside it. Instead of constructing that bunker in its final location, the way SpaceX did at Pad 2, teams are assembling the bunker frame off to the side, so it can be lifted into place the moment the pad underneath it is ready. Same lesson as the two-ship test campaign. Never let one bottleneck stop the whole build. Compare that redundancy-first approach to what happened to a competitor just weeks earlier. On May 28th, a New Glenn rocket exploded during a hot fire test and damaged Blue Origin's only operational launch complex. One single point of failure, one launch site, and an entire company's flight schedule slowed overnight. SpaceX's answer to that exact risk is 5 planned Starship pads, 2 at Starbase and 3 at Cape Canaveral, specifically so that a problem at any single site never stops the whole program, the way it just slowed New Glenn's. That's the through line connecting one unusual test to a 5-pad infrastructure plan. It's not really a story about one ship having a bad day at the test stand. It's a story about a company that has engineered its entire operation so that a stumble on one ship barely shows up as a blip in the schedule. Ship 40 stumbles. Ship 41 is already rolling. One pad needs a rebuild. A second one is already being poured. That's not luck. That's the system working the way it was designed to. That's the story hiding inside 15 seconds of engine fire. Thanks for digging through the data with us. Like, share, comment, subscribe to the Space Brief, and tap the screen for more.